Okay, welcome back. I'm hoping today we're going to be able to get some kind of volume adjustment done on our game today. In the terms of adding our function to determine how far our player's X position is from a given biome location. Okay, so where do we even start with this? I think first I kind of want to look at when does this end? 3 days. We only got 3 days left, and I'm really busy with work these next couple days. But that's okay. We're just gonna do as much as we can do in the time we can do it in. It's not a huge. It doesn't need to be a fully playable game. I'm just trying to make something. So let's see. I guess the first step we can do is see if our game even boots right now. It does. So see how the X position is controlling how loud the sound is coming out. We want to do that, but change the position so that 0 isn't in the bottom left corner here. 0 is going to be a predetermined, what I'm calling like a marker, a biome marker, and that'll set the 0 point of the fade in, and then wherever the biome is placed will be the actual location of the biome. So I guess a good thing to do would be to, in our play state, well, I want to instantiate a biome so a biome takes in 5 parameters. It takes in a name, an X and Y, and then a marker X and a marker Y. So my goal is to print out an image for the biome. So like we might actually need color or something, but we can do love.graphics.rectangle, and then we can do that in the fill mode, and we can draw it at the mountain biome is what we're going to spawn, and we're going to put it at the top rightish area. So we're going to need its X to be maybe, what is our resolution we're working with here? 1280 by 1280 wide. So half the screen would be 600, so maybe like 450 or 500 for the X position. 450 for the X position, and actually, let me look at the, I don't think it needs a fill mode. Well, actually, crap, no it might. Come on. If we can get the biomes and the sound working, I don't think we're going to get the particle. That would be really cool if we can get the particle stuff working in the next couple days. But I would be happy with, yeah, we do fill, then X and Y, and width and height. So let's do, I think single quotes can work for it, even though the documentation shows double. If our Y is going to be maybe like 50 pixels from the top, and then our width, we're just going to have a biome of 20 by 20. And I want our player to be 20 by 20 as well. But we need to, just because we put this in render doesn't mean it will render, because we have to instantiate said mountain biome object. And that's a variable that we're going to store our biome instantiation. And we need a name, which is mountain. Maintain. We need an X, which is C, and actually we need to do like we need to give oopsie. We need to give our biome a width and a height. We really probably need to give it a color too, kind of, but instead of that, I'm just gonna say we're gonna love.graphics.setColor to be equal to, we just want like a blue or gray value. What's the good? I guess Adobe Color's where I go to for color. So we want like a blue-gray, something like that. So if we click on this, how do I get RGB? Okay, 96. Whatever. Let's just try to do that. Our red is 96 out of 255. Our green is 149 out of 255. Our blue 247 out of 255, and then our opacity. I guess I always thought this was opacity, but so we need to instantiate these here in the arguments here. Those will get passed in and be set equal to its own X and its own Y. So we're not hard coding in every instantiation of a biome at mountains X and Y. We're doing it to the appropriate arguments. They get passed in as parameters. And then same with this I mean, I guess it's really okay because it doesn't change, but this is the better way to do it, I guess. Okay, so in our play state, we say mountain biome gets biome at this, which is whatever, 2020. And then we don't update anything with it, but we need to render it. So we would say mountain biome render. And what this is doing is saying everything in the mountain biome class, everything in this class, go use the render function from that item. So it's going in here and saying, hey, this is the biome render function. So we're going to set the color to blue, draw it at its appropriate position. So yeah, we render both our player and the mountain biome. The biome right now is just a square, but we need its X position to be tracked so that we can set the marker point and test our Pythagorean theorem implementation. Cool. So yeah, the biome is right there. It's rendering it over our character, which is good. So we've got a mountain biome. And that'll allow us to start to be able to print out all of our debugging. Which is really cool. Gosh, I made this iced coffee that's really freaking good. Just put like a little splash of creamer in there. It's like so freaking good. Okay. Well, we've got our mountain biome rendering. Now we need to set the marker point, and then yeah, instead of starting player here, I'm going to give us a constant called ground height, and we're going to just set that to be 100. And when we instantiate our player, we're going to be giving it ground height, well, virtual height minus the ground height. Right? So that we can adjust. We don't want to spawn on the bottom of our screen. We want to spawn on some sort of ground. It can be about twice as high as that. Shoot, but yeah, we don't want to be able to move beneath it. So let's, at least not yet. Let's just say ground height's twice as big as that. 200 instead. We're going to have to lock in the player controls a little further down the line once we can figure this out. Because we also need to be able to plot where the different biomes are going to be and determine which path we want our player to be able to take. So, yeah. It's a little tricky, but maybe we'll figure it out. This is the whole point of it, is like trying to code something that you haven't made before. That's why CodeJam is so cool, because they released the theme, you know, so it's like, well, what do we do for weather? I don't know. Let's implement this idea I had where we, you know, try to play different mixes of sounds depending on which biome you're standing in. So you kind of hear different weather sounds depending on your person's location. Because I thought that would be a fun little app or experience, almost like a meditative, like, you know, explore this environment and listen to how it changes. So we need to give ourselves the Pythagorean theorem function, but we also need to, when we give us a marker X, marker Y, we need to set those equal to an actual variable. Because we need to be able to also print out a biomarker. So we're gonna have code in here that not only renders the biome itself, the biome placement, but it needs to render the biome marker. At least for now, while we test this. And we're gonna set its color to something bright red or something, you know, like, so that we can see the marker easier. Uh-oh. Actually, was GIMP just, hold on. Come on. That looked so crappy. Yeah, look at that. That was all of our beautiful artwork from the other day. So yeah, we want biomarker to be red like this, so we can do, look at this, 9144. So we could do 9144. Oopsie. 9144, full transparency. And then we're going to do the same thing, except instead of printing the biome placement, we're printing something at our marker X and our marker Y. And sure, why not give us the same height? And we're setting our color. So this should be, we should have a blue biome for the mountain, and then we should have a red biome marker wherever we put our said biome marker instantiation as the parameter passed in, which we currently are not. Wait. Oh shit. I tried to, okay, well, I don't know if we need this just yet. I had earlier, I had put the instantiation of a biome into the player class, which I'm not exactly sure is the best idea. That's just how I had it, but I'm thinking it makes more sense to have it in the play state here, which I've done in this episode. So here is the parameters, name, X, Y, and then actually, yeah, the other parameters in mountain in our biome are marker X and marker Y, so that wasn't width and height. It was actually marker X and marker Y, so we need to change that. We weren't rendering anything. Actually, no, the biome would have had a width and a height set to 20 automatically. In there, though, not when I passed it in there. Okay. So yeah, that mistake luckily didn't break anything. It worked fine because we weren't actually using those parameters. But it's got a name, an X, a Y, and then a marker X and a marker Y. So our mountain biome X and Y needs to be, if here's the biome, it needs to be to the left of the ladder, start probably at the bottom of the ladder. So the bottom of the ladder is going to be virtual height minus ground height. That's going to be our Y, and our X is just going to be wherever we determine our ladder should be, which if we print up a X position of our character, we should be able to see, so we can place it with less guesswork. For now, I'm going to leave it blank, but I will in our player class. Actually, no, in our play state. I'm going to render to the screen some debugging that does a love.graphics.print, and the thing it prints is, actually, we need to do a couple things. We need to set, we need to set our color to white before we do this. Well, really had to set color twice like that, huh? What color was this? Gray? This was gray, and this is white. Yeah. Huh. I guess we didn't need this. But I'll put this after we change our font color to white and say printf. There's a difference between printf and print, but I think we can get away with printing debug on just print function. So we're gonna print player X, because remember we're trying to see what X to instantiate our biomarker at. We're gonna print, but we're gonna print a string of that, and it can print that no problem, but we need to concatenate that with our player. Our player object is just called player, so players.x we will put concatenated after that, and it needs 2 more arguments, the x, which can be 0, and the y, which can be 10, because we're printing our frame rate on screen, so I'm just going to make it below that. Biome, bad argument 2 to rectangle. So it needs an x and a y there, just to be able to compile and play, I guess. So we'll just put in our 20s for now, like it was, even though that's wrong. I don't see it drawing our, oh no, I see a rectangle drawn. It's not a very bright red, but it's not also, hold on, maybe this needs to be 30. And the mountain biome needs to be brighter. This needs to be like, I don't know, if this is 130 and this is 130, or max out our red channel, make it bright red, and then we'll see how that looks. Yeah, not so much bright red, but it works. If we just have these into 60, should be brighter red. Now our marker X is clearly wrong. It's just at 20 and 20, which is why it's up in the corner there, but we're looking for our debugging, printing out our X position, and we need to determine where our ladder should be. So our ladder may be here around 240x. So if our ladder's at 240x, that means 240x. That means when we instantiate it, we draw it at 240. 240 is the marker X, and then the Y would be our virtual height minus our ground height. So now this should be, now our biome marker red square should be drawn right here in front of our character. And it's just down and to the left of our mountain biome, which we'll have a little ladder here for. Oopsie. Okay. And then we'll do this. We'll give a little more buffer here and a little more buffer here, just because it was cutting it off. Okay. Yeah. So since, see how the red is kind of aligned with our player's top left, which is actually perfect because we need that to be, or like it makes sense because everything's drawn from the top left. So the player's in this position where the biome marker is, that should be the 0 tween value instead of the 0.2 it is now. So we need to calculate the tween based on the current player's X position, but not relative to the whole screen. And then we need to do the Pythagorean theorem math to do the hypotenuse distance. And then we need to assign our distance converted into a tween value based on that biome marker position. Gosh, crazy. If that makes any sense to y'all. God, that's good coffee. Okay. So, I guess let's figure out how we're gonna do our volume, we want to find wherever our current tween values are. Where do we do our tween value? We initialize it to 0, and then we say right here, test tween values for left and right. So the thing is, we need, we need to test the hypotenuse code, right? Because we need to determine the distance our player is from a biome marker. Not marker, but a biome place. Our marker is our other point of our triangle. So we need to say something like, if player's x, if a value that player has, which is, we need to store the distance, we need to store the hypotenuse leg distance for each biome and their biome markers. We need to store that in the biome somewhere, so we can say, hey, calculate this tween value based on the, oh my god, how do we do this? Does that make sense? Do we put into our biome class, we put in a variable to hold the markers? That's what I was thinking of earlier, because I had this is one of the reasons I stopped early last time, is because I didn't know how to implement this. Like, I'm basically like, do we make marker a class so that it's one variable that has two values, which could be useful. I guess let's see, because the thing is, the player will need, we need to check the player against every length of the hypotenuse leg of every biome. And if it is smaller than, if the distance between each biome is smaller than the hypotenuse leg distance, that should trigger the tweening to be set positively instead of just staying at 0 on the mix. So we need to store at least all the values of the hypotenuse leg in relation to the biome markers into the biome instance. Does that make sense? So we can say hypotenuse leg gets, and then we assign whatever the distance of the hypotenuse leg is. Then every frame we run our hypotenuse code, our Pythagorean code, and if our biome has a value for that code that is smaller than it's so hard to explain this. We'll try this, I guess. I'm a little confused if I need to have an instantiation of markers or not. But I think we can get away with not using that if we God, I don't know. It's almost like feeding in whatever the parameters are here should spit out an assigned field. Yeah, like we should say, once you init this object, we get a field called hypotlength, and that gets assigned to, and then we literally need to do the Pythagorean theorem on our given parameters. So we need to say, how do we do this? It's like, because the thing we're trying to calculate the length for is, we only have 2 points. We have the biome and the biome marker. So we need to, how do we do this? Let me just draw this. another art piece. We need so we've got this point. Come on. Come on. Stop trying to hit me and hit me. Here. Gosh. Okay, whatever. Give me 2 eraser. Oh my gosh. What are you doing? Really, why are you doing this to me? Why? Sorry guys, it feels like every time I go into GIMP I just like crap the bed. We need P for pen tool, but we need... Okay. There's our biome place. Well, that's awful. Biome place, and then we have biome marker. So the question is, how do we... This would be, this imaginary dot here is our A, or is like aligned to our side A, to our side B. So how do we find, it's like we need to say marker A, or if this is, gosh, yeah. So maybe we can call this like our 90-degree point, since this makes a right angle. So if this is our, even though we're only given 2 points, we make our third point based on our markers Y, but our biomes X. That point will become point C, or whatever we called. And then we need to calculate the hypotenuse leg based on that. So I wanted to write a function for this. And maybe the place to do it, I don't know about this, is the place to write this function here in the biome class, because we only need it for the biomes. Well, I guess we might need it for other stuff. I guess we'll put the function in our main state, and then we can use it in everything. Is that how that works? Basically, let's just write the code for it first, because we need, it would be, you know, it would be called function function get hypotlength, and it takes in gosh, I don't know how to do this. I know we need to, maybe we say like assign point A, assign point B, assign point C. Then once you have all the points, then you use Pythagorean theorem. So we need to pass in 3 arguments. One is point A, so it's an X and a Y from our biome marker. So we have biome marker. I guess I can use the same values. my question is, like, since I'm using marker X as a parameter here and marker X as a parameter here, is that okay? Because I think it's all, shoot, I don't know. It would be the same X because it's the same. Yeah, I don't know if we're going to keep this function in this class, or let's just try. If, we need a marker X and a marker Y for our C point, and we need, we'll need to, god dang. I don't know. We've got that. We need to determine our, this would be a biome X and a biome Y that gets passed in. And then our third point is our 90x, our 90 angle X. And our 90 angle Y, which we would need to calculate. Well, actually, yeah, we can actually probably calculate that and assign it here instead of requiring it, because we can create this out of these 2 points. So we can actually just take this out and put it here somewhere. So right now, our getHeight_length function takes in 4 parameters, and it needs to be run on a biome object, because a biome object is promised to have these 4 parameters that we need for it. So, like, let's say that I guess that would mean that our A position gets this. Oh gosh, how do I do this? Self A.x. That's so weird. So, like, what I'm doing here is giving myself 2 variables of the points, because we're doing some, actually, yeah, we might not need this, because if we just know the, okay, let me see. How do we calculate point C? We need to say that self CX, self CY. So our C point gets our biome markers Y. So our C's Y gets our biome marker Y. CY gets our biome Y. Oopsie. Biome Y. While our CX gets our biomes X. Yeah. Our CX gets our biomes X. Okay. So that will, these 2 positions give us the point C, and then we won't need to actually assign these, because we can just do, since we technically have point A and point B, hold on a sec. I'm trying to think if this will screw us up if we get negative numbers or anything, because if I'm drawn on the other side, we need to calculate, actually it would just be a squared plus b squared, both of which would be a positive number. But if we're above the biome, then we would need to take the absolute value of our a and b. So maybe we account for that. So let's maybe take these out for now and see if we can see, because right now this function doesn't actually do anything. We want it to return a value. We want to return a hypotlength of whatever comes out of this. Or like we need to calculate it, assign it to our hypotlength, which means this would need to be after our init function, I think. But before our update function. And yeah, because we're assigning it just any value, so we have it. I guess that's a good thing to test. If I take this line out, will it yell at us? Because of it has no prototype or whatever you want to call it. I guess that wouldn't be a prototype, that would be a initialization. And I think you can only initialize in the init function instead of another function, but I'm not exactly sure, but that's something to test out. So what is the Pythagorean theorem? Well, you know, can you do exponents like that in Lua? A squared plus b squared. Now, you know, we have points, we don't have distances for this. And then we'll need to solve for c squared. So we need to say, we need a, which is a length between point A and point C. So to get that, we just do our current x, or we can do, yeah, what do we do for that? We need the length of our A, which is our distance from our biome marker to our point C. So if I'm trying to think of it on the other side too, because we can't just say the distance is point C minus the x position, cx minus our a length. We'd have to figure out this a length. What do? We just subtract, you know, we have this x, we subtract this x to give us this length. But then if we're on the other side, we can't use that same formula. We'd have to say it's actually this x. What do we do? Fuck. We would say if the point's over here, we'd say take this x, subtract that. So how do we say that in code? If A is smaller than C, what do? Let's do the smaller than C first. So if AX is smaller than CX, so if biome marker X, if marker X is smaller than self c.x, which is our biome parameter, our biome X, which is technically right. Yeah, if it's on the left side of our biome marker, then calculate a length. For this when right angle faces left. I don't know how to say that because it's like, you know, actually, yeah. So I guess this just depends on, do we always want our biome marker? So it's almost like a, gosh, this is so interesting. Because it's like, the biome marker is not only a trigger for it on this side, but if it's the corresponding, like let's say this dot is the same distance between, you know, its length A here, then there's also a cone coming out like this, and this is our cLength for when it's on the other side, and this it'll also trigger. But then what I was thinking is, like, if we're right here, this length, this cLength, goes out to past here, so it would be like a 20% mix or whatever, you know, when you're not on those. But I think the goal is to design a world that if I'm over here and I hear some of the wind because I'm directly underneath the wind part, that might be okay. Like that's kind of the whole point of this kind of radial adventure, or whatever you want to call it. So if marker X is smaller than C.X, calculate a length when facing right or facing left, and then otherwise we need to calculate a length for a different sized or different shaped when right angle faces right. But does that mean we need to it's hard to imagine on all the orientations, but a length, and we need a self A, a self B, and a self C. I guess just initialize them to 0. Okay. Okay, let's try this. This is for our A, calculating our A. We need to calculate our B now. How do we calculate our B? Well, our B length is the y difference between our point C that we created, our point C's y, and our biome place y. So it's like the B needs to be the absolute value of, how do you even put this? Because if point C is above the biome, we would say we take biome B's y, subtract C's y, if it was above it. But since it's below it, we would say take C's y, subtract B's y. So it's like we got to do the same thing on the same thing we had to do for the X over here. Just for the Y. So we need to say, like, if our self CY, is that what it is? Self CY. See, we need to give ourselves this up here. Fuck. It's like, I think we need to give ourselves cx before this. Oh god. So if we give ourselves a cx, initialize it to 0, give ourselves a cy, initialize it to 0, so we can use those variables. We use those variables in this function of get pythagorean, and we're figuring out for our b position that if our cy is greater than our by, if our cy is greater than our biome y, meaning our C point is below our biome, then we're going to calculate our b length for, what do we want to call that? For floor triangle instead of ceiling triangle, you know, because we need to do the ceiling triangle as well. And by ceiling triangle, I mean the right angle is on the bottom of this right angle square when the C point is beneath the marker point. But if the C were to rise above the biome, which we're planning to have other biomes lower, so we need to consider that too. If our C point's above that, then we need to do different logic, and that would make, actually, yeah, ceiling triangle and floor triangle don't make a lot of sense, but it would be like a triangle above the point or below the point. I don't know what to title that as. So it's like for lower triangle or higher triangle, is greater. Okay, so we need to assign our a length here. Our self a length gets now updated to the appropriate length depending on the orientation of the triangle. And we're saying if our marker's x is greater than our self c dot x. Gosh, I already think this is wrong. Marker, no, yeah. If our marker x is smaller than our c dot x, okay, no, that's right. Then our a position is going to be just like this, and we need to say that this value a gets our c position, or our cy position, our cy minus our marker y. Cy minus marker y. Does that make sense? Is that right? The difference between our y's. Is that the way to look at it? Cy minus no. Because I'm trying to convert points into length. Not sure if that works like that. But it's like it would be, yeah, the number of pixels between our marker y and our C point y. So if we start at 10 pixels in and we're 10 pixels wide, we would say 20 minus 10 gets us 10, which is our length. But if we're 20 pixels in, and then another 10 pixels in gets us our C point, we would be 30 minus 20, which would be 10, which would be our, okay, yeah. So it's just our CY minus our marker Y. No, our CX. Our CX minus our marker X. Yeah. Yeah. So it'd be our CX minus our marker X, which is at self marker X, and that's passed in as a parameter when we initialize. So our self A, and A is a length. Maybe we should say like A length or something, just to make that a little more verbose, because when we're doing points and distances, it's just a little confusing to me. So like this is a length, this isn't a point, if that makes sense. So self.a length gets assigned our self CX, which at first is 0, but we assign it our biome X parameter, which is this X and Y. So I wonder if I don't know what to do there, but we can say, oh gosh, hold on. So the question is, if we use this biome X, this is a parameter getting passed into the getHyPyLength on the biome function, but this biome X is a parameter we already got from the init function. No, yeah, it's this one. So maybe we say that this hypot_length doesn't require any arguments, because we know, given our biome position, our biome object has our biome position, X and a Y, and a biome markers, X and a Y. So all of these arguments we don't want to ask for again, but we do want to say that this is probably called biome X. This is called biome Y. Therefore, we can use those here. So this would be biome X. I think this is the right move. I wouldn't want to use that same parameter more than one time, because we're given it doesn't change. Like the hypotenuse distance length will stay the same. It just depends on where we spawn it and where we spawn the marker. So we don't need to do anything fancy. This would be now biome X, and this would be biome Y, and then we can use this Okay. Now, and since we're running this get hypotlength on a object of a biome, then we directly influence that biome's CX position and CY position based on what parameters were passed in for its second and third argument here. Yeah. Because all C is biomes X with the markers Y. Okay. I think that's right. So now we've calculated a length when our marker X is on the left side of our biome. But if it's on the right side of our biome, we need to do something different. We need to calculate a length, assign a length the proper value, which would be if our X is greater than the CX. So if we're over here, our A length would now be our marker Y, no, our marker X minus our CX. Is that right? No. No, it would be our CX. If we plus 100 to our C, this would be 200, 100. So we would say, oh, fuck, what do we do for this? I mean, because I'm imagining over here, you know, if this is where our biome marker is, yeah, this is where our biome marker is. Fuck, wait. We can always say, no, yeah, we can always just say the biome marker is going to be set to be a this angle rectangle. Because it's mirrored anyways, right? Because we're in control of where these biomarkers get instantiated, so we can just say anytime we make a biomarker, put it to the left of the C point. That way it doesn't fuck with all this other stuff. Because we don't want to necessarily calculate a new we don't, yeah, I guess it's like we just don't need to really do that. We don't really need to do that. We could but I don't know. We'll see if that runs into problems because we need to calculate our B length as well. Basically, I'm saying if we play nice when we spawn our biomarkers, we can ensure this similar math be done appropriately. So the formula for calculating our A length, which is this, as long as we select our biomarker to be left of our point C or left of our biome C, X, or yeah, biome X, then we say it's just this point C minus this point X, or length A. CX minus our marker X. Now we're looking for B length, which is going to be, it's going to be C's Y minus C's Y, yep, minus our, shoot. No, it's going to be, why is this so tricky? We're looking for the length B. So the length b would be not the number y here, not c's y here, but it would be cy minus whatever this is. Whatever this is b's y. So cy minus by. CB. Cry. Baby. Okay. cy by. cy minus by. So self dot cy minus, it would be biome marker y, biome y. Is that right? cy minus biome y. cy would be this one, but that would be too long. We need to subtract the y of b. Okay. Okay. So that looks to be our b length. Then we need our hypotenuse length, which we're going to do here. And instead of hypotenuse length, we need this to be c length, which we've already got up here. So instead of self hypotenuse length, this is now self c length. Now, we need to solve for c. So it's like we need to say, you know, a squared. So our self dot a length squared plus our b length squared b length. We can, multiplying by 2 is the same as square in this scenario. I mean, I guess it's always, no it isn't. No it isn't. It needs to be squared, not times 2. It's not the same thing. Can I do that? So I guess my question is, how do I do square root? Love 2D. Because we need to calculate, we need to solve for c. Oh wow, look at this circular collision. That's awesome. I'm not quite looking for that. I'm looking for just a square root. You gotta use SOHCAHTOA. It looks like there's a function called math square root. Math.sqrt. So we're going to say c length is the math dot square root of a squared plus b squared. And then, so this is our get hypot length. Maybe we call this get c length, I don't know. I mean, hypot length makes sense, I guess. Yeah. Let's maybe just see that. So we need to actually run this function. It doesn't take any arguments, but it does have an effect of updating our cx and our cy and our a length and b length and c length. So we need to run this function. Oops. We need to run this function. I guess we run this function in the play state. Like we need to know if we do it here or what. We need to say, so the thing is, the input of this function is nothing. So when we run this function, it'll take the biome x, which is the second argument here, and assign it to our cx. Okay, so basically I want to see if we just run this function, like here, for example, we say mountainBiome, oopsie, here we just run it here. We say mountainBiome, use function, pythagorean. That'll update all the special C values and whatnot. Then we want to print out some values to see if this is working right. We want to say, hey, this is our, like maybe our A length and B length might be nice to see, but we really want to see our C length because it should stay constant, because C length is not determined by moving player. It is determined by the distance between the marker point and the spawn point, which are right here. So we're going to concatenate to a string our mountainBiome cLength, because this field cLength gets populated in, and once we use our hypotlength, our cLength gets populated to be the square root of a squared plus b squared, which should spit out, I'm hoping it should spit out a constant value. Because it shouldn't be changing. We'll see if it even compiles or whatever. Bad argument 2 to rectangle. Biome 47. What did it say? It couldn't render the rectangle because bad argument 2 to rectangle, number expected. Argument 2 on 47. Argument 2, number expected got nil. So why is our, our self x is now our biome x. Self dot biome x. Self dot biome y. Marker x, marker y. I think that's okay. So look at that. It looks like our cLength is indeed a stationary number, and it looks believable, which is a good start. I'm going to print it a little lower. lower than this. Now, I am not gonna play sound because as good as it sounds. So see how our cLength stays the same no matter where we go, which is good. So if top of the screen is, oh, we need to print out our Y value a bit. But you know, this is 210 distance X. Gosh, that doesn't look right, does it? C looks like it's 600. Let me print out. So if this is by 50 difference, we can say, oh no, 90 is a 40 offset difference. So in our constants, we can just say debug offset gets 40. So that we can print out our other values. And we say this would be the last, gosh, plus the debug offset. Gosh, I mean, I guess it would just be debug offset is 50. God, sorry guys. If this is 50, then we can say debug offset times 2 and then times 3 and whatever. And if this is times 2, so I just want to print out, this is actually going to be a length first. I just want to see if those numbers are looking believable. Which 200 for a cLength seems too short. ABC length. So let's print up, and those should all be stationary values. Yeah. See, look, our B length is 0, which is not right. So how are we calculating our B length? We're saying our B length is our CY minus our biome Y. So then I guess the question is, does our CY and CX print up any useful values, or are they still nil? Because that would be messing stuff up. So we're going to say our CX and our CY, self.c, is it self.cx? Yeah, self.cx and CY. These aren't being assigned appropriately. CY. I'm guessing these are 0 or something weird when they shouldn't be. Our cLength and CX and Y. Hold on, sorry guys. Where's our tween value being printed? Are we printing in the, yeah, printing here? Well, let me just say this. CY isn't getting set appropriately. So why is CY not getting set appropriately? In our biome, Our CY starts. See, it shouldn't be nil. Like, we at least set it to 0 here. But we set it to self.biome y. That should work. So y is cy. What's weird is cx is getting not nullified, but cy is. We don't do anything to cy. Like, if we take this out, cy should be 0, not nil. Not nil. And 450 comes out of, is it right there? Because if we take that off, does it say cx is 450 still? No, it says it's 0. So why does that happen? Bro, they're the same freaking code. How would they do something different? This one turns it into nil, turns cy into nil instead of 0. Why does it do that? When I turn this one on, it turns to 0 as appropriately, or actually it turns into not 0. It turns into a real number, not a nil. So where is our cy not getting? It shouldn't be nil. Cy should not be nil at this point. We've got cy right here, not nil. So when we render a biome.cy, actually, hold on, let me see that. Yeah, oh. God damn. Isn't that always the case? Okay, now cy is working. Now we can turn that back on. And then now, hopefully, our c is the real number. No. B-length is determining 0. B-length should not be 0. B-length is cy. C? Okay, this is wrong. B-length, how do we calculate B-length? B-length is our cy. Cy gets... Oh, I messed this up. Our cy doesn't get our biome y. It gets our... God damn it. If cx... God damn. Okay, let me think about this. Cx needs to be our biome x. Cx needs to be biome x. Cx is biome x, yes. Now cy is our marker y. So cy is our marker y. It's our self marker y. That should give us the correct cy, that should give us the correct b length, and that should give us the correct c length with the Pythagorean theorem. So now that looks about right. C length, the distance between this biome marker and this, or actually this biome placement right here, and this biome marker is 550. That sounds about right. Closer than the 200 it was. So now the idea is, now that we know that distance, we need to calculate our layer's C length. Real time, and then compare it and adjust depending on the biomarkers. So I guess the question is now that we're doing C length on 2 points that aren't hard-coded in the correct shape, you know, I guess do we just do a simple check of like for every iteration? How do we do that? Because calculating a cLength is going to be different math depending on where in relation to the biome we are. So it's like we need an all case scenario to calculate our cLength from our character to our biome. And then once we have those distances, we only trigger the tweening value when our cLength is less than that cLength threshold of our biome markers. And then instead of tween being 0 all the way to the left and 1 all the way to the right, it'll be 0 if our cLength is the same, if our distance to the biome point is the same as we set it to, and then it should be 1 if our distance is nothing, meaning we're on top. So fully loud up here at this biome, yet all the way silent if you're down here. So yeah, that's the idea, and then I'm hoping it's almost like we need, as long as we keep the biome markers drawn down and to the left of whatever our biomes are. Well, actually, yeah, that needs to be different. Because imagine like a biome down here and our characters up here. We need to calculate our cLength differently because it's going to be a flipped triangle. I think we can do some. Actually, maybe we just see, because the thing is, if let's say our biomarkers on this side for whatever reason, then the math of it should be our C's Y will still be our biomarkers Y. CY is biomarkers Y. And our CX. Oh God, it's so hard to envision this. Our CX, if we're over here, if the biomarkers on this side, our CX would be our markers X. Not our biome X. Yeah, so C.X. Oh no, yeah, that's right, because the marker, well, yeah, C would be down here. Okay. Okay. That might actually work. I don't know about, it's hard to step, fuck. I mean, I guess we can see right now, like, does it mess up? No. It calculates it for the one. I guess the true test is to move this. Now that we've got a marker on the left side, let's do our marker not at 450, but let's do it at the corresponding other side, so virtual width minus that 450, and then we see if our C is still 550 or whatever it was. C we moved, oh, that's not right. We moved our biome when we wanted to move our biome marker, so 450, 240 is the number I was looking for, and we needed 240 pixels from the left to give us that same virtual width minus 240. Now we'll see if our C is still the same. see, that's not right. We've got a cLength that's actually correct. But what we're messing up is our A-length, which needs to be our A-length needs to be a positive number. So we can say math.abs this. And then I want to say this one also has to be that, but I don't exactly know. Positive number now. That looks twice as far, doesn't it? The biomarker. It looks twice as far. Oh yeah, because it wasn't. Okay. No, yeah, it is. And cLength is 800 now. Oh, well, that gives me good confidence. Because now it looks like A-length is 590 to 550. That makes a hypotenuse of 800. So we might be good. See, so now the question is, if we put our biome lower, we put our blue biome down here, and then have a marker up here, does it still give us appropriate A-length and cLength and whatnot? So we can actually just swap our, I'm going to swap this back to positive 240, and then I'm going to lower our, actually, we want our biome to be lower. So, oh gosh, yeah, we want this one. So instead of 50, make it, I don't know, 1050. And then where does that put our biome marker? Not what I wanted. Where does that put our biome marker? That's off screen. So let's just do virtual height minus this ground offset. Ground height. Let's see. Okay. So we need to put it lower. We need to put it lower. Yeah. So does this give us, this gives us a positive A-length, which seems to be about right. B-length seems to be about right. And cLength seems to be about right. They're all positive numbers. Okay, so we should be, I guess the only thing left is like if our biome is way to the left here. Instead of 450, it was just 20. And then does the hypotenuse math still work? We've got an A-length of about 220, yep, which is just that. Yeah, yep, okay. A-length 220, B-length 130, C-length 257, that sounds all right. So it looks like our hypotenuse function is working correctly, which is really nice. I wanted to put this kind of back to where it was. Was this at 450? And the Y was, what was it? 200? I don't remember what it was. 250? It was higher than that. I don't know, man. I don't remember exactly where those were before I started messing with the values. that sounds about right. So one thing I'm thinking of is we might want to floor this cLength so we don't have any weird decimals. But I guess it doesn't really matter. So if we floor cLength like that, now we just get a rounded, truncated hypotenuse length, which is fine. Okay. So now we need to worry about, damn, it's so tough. Yeah, now we need to do the same thing, but for our character. So instead of this biome marker X and Y, we need it to be with this updating X and Y from our player. So yeah. You think we can figure that out today? Part of me thinks so. Part of me thinks that's a lot. But I need to get going. We got, we've got only 3 days left on this game jam, and it would be nice if I have the stuff set up for me next episode. So I'm gonna take a quick pee break. I'll be right back. I think we could do this, y'all. Not too bad. Instead of a... See, it's almost like we need this. We need this get hypotlength for our player. So if it's before the update function. So we have a function that needs to be called on our player object called getHypotLength. Basically the same thing, except we need to assign a point C, which doesn't get set to a marker Y, but to a self.y. Actually, it's just self-y. Self-y gets moved into our C point Y, and our biome, our CX would be our that's not right, because in this point, so okay, so where is our CX? Where is our point of our X position of our right angle when we're calculating it based on the biome and our current position? So it's like, why do you not let me do this, man? Give me a layer, give me it white. Now, when I erase this layer, want to see the layer underneath. Why do you do this? Why does pencil work but erase not work? Pencil works but erase don't work. I don't get it, but whatever. Okay, so let's say here's our biome, and let's say here's our player. Our C point is this value. So our C's X needs to be, it needs to be our biome's X biome X subtracted by our C's X needs to be our biome's X, period, right? If we're calling, I'm going crazy, man. I'm going crazy trying to think about this. Our CX for our character would be our biome's X. CX is biome's X. Okay, biome's X. But our Y, our CY, is our player's Y. So we need our CX to be biome X, which is what we have. But see, this is in return. Oh, fuck. I don't know how to do this, man. Because right now, biome X is a item that belongs to mountainBiome. Because we need to calculate all these different points for all these different biomes, not just the mountain one. So for now, I'm just doing mountain. Our CX is our mountain X, our biome X, and our self Y. Our CY is our self Y. That's what I have. And then cLength is our CX minus our marker X and C. This is different. So look, our cLength, which if this is A, no, this is A, this is B. So our cLength is going to be our CY minus our self. Our CX, god damn it, our CX minus our self X is A. Our CX minus our self X. And our CY is going to be our self Y. Is that right? Oh no, we need, we're trying to do our BY, or our, damn it. We're trying to do cLength, which is going to be our CX, or CY, our CY minus our biome's X. No, our biome's Y. Yeah. Okay. Maybe? Okay, so I think we need to give ourselves a cx and y up here. Cx gets 0. Our cy gets 0. And we assign them after we use our getHypotLength on our player object. And that also populates 3 more variables that we need. At least I think we do. That we need initialized here. God damn. Okay, we need a B and a C. And now we should be able to do that. Now we need to run this function in our play state. We run this getHypotLength on our mountainBiome, but we need to run this on our player so we can get our player's hypotenuse. So instead of drawing cx and cy of mountainBiome, we're going to draw cx and cy of our player. And see if, since this is in the update loop, it's going to update our hypotenuse length for our player versus our biome. So now our cLength should now become variable. And same with our A length and our B length, because we're updating our position now. So as far as the biome square is concerned, it's a fixed triangle, but when we need to compare it to our player, we need to see what, great, biome y is a nil value, player 35. MountainBiome, is that what it said? Mountainbiome's a nil value. Biome y. Biome y. Oh, not self-biome y. MountainBiome y. So this means, I think this might be right. Because yeah, look at how that's a 0 triangle, because I'm right there. So now we can say, do you remember that when we're right here with the biome marker, cLength is like 530 or whatever. Let's just say 530. So now, since we're calculating, since this is bigger than 530, see how we're bigger than 530, that would mean we would be at 0. Once it gets smaller than 530, you know, however much smaller than 530, play that tween value between 0 and 1. So that's looking good. That's looking like it works. So the tricky thing comes in where right now we're hard coding this hypotenuse with a mountainBiome, which this probably needs to be passed in as an argument. Like we'll need to run getHypotLength on every single biome. Yeah. So we'll probably make that an argument at some point soon, once we get some more biomes placed. But I guess for now, the real question is if we can get the tween value to be set not to be between our width, but between our, god damn, how do we do this? You know, we need to compare our cLength, our player's cLength, with our biome's cLength, and do different things. So like, if our cLength is smaller than, here, let's just, what do we do? We want to change this tween value only under certain conditions. And those conditions are, I'm going to just comment this out real quick and try to do a new one. We're going to say the tween value assigned to our player field called tween is a variable that gets assigned only in certain scenarios, and the scenarios are if our self.cLength is smaller than maybe we say if our cLength is greater than our mountainBiome cLength, to do nothing, right? Or like if our cLength is greater, then our tween value is just gonna be set to 0. Like, it has to be, because it's further than our hypotenuse of our character is bigger than the length of our biome marker, so tween value will always be 0 in that case. So we need to say else, you know, if our tween length is smaller, else our tween value gets set to be, it needs to be a number between 0 and 1 depending on our cLength, our biome cLength. So it's like, how do we do this? We did this by saying the tween value gets to be its current x position divided by the virtual width. So it's a proportion of the width. So the width would be the cLength, and then the self x would still be relevant, but we need to check. It's not the self x. We're not trying to adjust it based on an x position, we're trying to base it on a length position. So we're trying to say, like, we're setting it to be equal to, if our cLength is equal to our mountainBiome cLength, we need it to be 1, a number, right? So it would be like, it would be self cLength over our mountainBiome's cLength, which, if we're the same, that would be a +1, which is correct. But if we're at, let's say the cLength is a number smaller than it's a ratio of our lengths. Oh, see, this is opposite. Like, it needs to be, oh God, when the the bigger self cLength is, the lower the number needs to be. Is that right? It needs to be 1 if they're equal. But as cLength gets smaller, that means we're closer. That means the number needs to be bigger. But if cLength is a small number, like let's say 2, then that means it needs to be super loud. It needs to be almost... What am I missing here? Does length look like it's spelled wrong at this point? That looks so wrong. Let me see what that does for our tween value. So it does trigger here, except it's getting smaller. You know, we want it to be, yeah, we want it to be the opposite of this. We want it to be, once we just pass the tween threshold, you know, we're 0 when we're outside of it, which is right, but we want it to be quietest when we're furthest and loudest when we're closest instead of the opposite. So how do we do that? We just swap this. Biome length. Oopsie. 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 Why did I do this? Why did I do this? Okay, so if we flip that, okay, we flip that. Now we have tween 0. And once we get closer, see, that's not right. That's not right. This should be 0. This should be 1. No, this should be 0. This should be 1. How do we do that? Well, I don't know. It's like, dude, it's just so weird for me to try to think of that. So if swapping these gave us the opposite effect, how do we reverse that opposite effect? Like, this was giving us a positive 1 when we wanted a 0 and a 0 when we wanted a positive 1. So can we say, I don't know. What? Yeah, maybe we just subtract from 0 the tween value. So 0.99, we say 1 minus tween value is our tween value. And then we say 1 minus tween value is our tween value. Yeah. So we need to say 1 minus this stuff is our tween value. Will that work? Yeah, we want it 0 down here when it's furthest. And then loudest, dude, that's it. And then the further we go away from it, it gets quieter and quieter and quieter until it's 0. Dude, that's what we need. That's what we need. Look, it's 0 anytime we're further than the marker, the biome marker, which means it'll be completely quiet. Then as soon as we creep in, it fades up till full volume when you're here, sharing its X position, and then quieter as you go farther away. That's it, dude. That's the basis of getting this to work. So if we go in our main, and we, actually I think it's in our play state, we now trigger our beeps on again. Now I want to see if it's working. So no beeps because our tween value is not triggered. If we get close enough to our biome marker, it should be playing beeps really quietly. Yep. Then as we climb the ladder, it'll get windier and windier. Yep. To the loudest point. So yeah. That's sick, man. That's exactly what I wanted. So now, you know, instead of it calculating the loudest point off the right side of the screen, it's going to the biome. That's cool. I'm so glad we could do that. So yeah, that's really sick. That's huge. So the tricky things with this is right now, our player get hypotlength function is hard-coded to our mountainBiome X position, which needs to change. We need to add a argument that we say this also takes in a mountainBiome. This also takes in, maybe we could do that right now. We say, hey, this, you need to pass in a biome for this player hypotlength because we need to ultimately pass in all the biomes. So we can do a loop for that, but we need to say the biome you pass in, that biome's field, biome X, gets assigned to our current player's CX. And then when we instantiate you, we say, hey, mountainBiome, or no, we say, when we use the function in our play state, hypotlength, we need to pass in the mountainBiome. And then if that works just the same, then we're good to go. Yep. Now, I don't know why we play the beep sound once. First, like, we need to say, so player.tween should get set. Why does, yeah, player tween doesn't get set to 0 right away. So player.tween is set right here, isn't that? Yeah. Yeah, as soon as we instantiate it, it should go to 0. So it's almost like, I wonder if I set it manually here, saying, hey, make sure your tween is actually 0, because we're getting that beep right there. I don't know how to fix that. I don't know how to do that. But this is taking mountainBiome. I guess the question is just, what is player tween set to? Is that set to nil? It happens so fast. OAN? I don't know what it's set to. But we're setting the volume to player.tween and playing. I don't know, man. I don't know how to fix that. I don't know why it beeps right away. The player tween value isn't getting set right away, which I thought it'd be set right here. I don't know. I don't know what to do with that. I don't know what to do with that, man. It beeps right away, and I don't know why. Tween is not getting set to 0 right away, but I don't know what else we can do. We're setting tween to 0 as soon as we init this player, which is the first thing we do in this play state. Yeah, and we even update our player before we set our looping. So yeah, I mean, even if we don't set it to play, it'll still say, oh, maybe not. It looks like it sets to 0. Are we tweeting? Where are we? Gosh. Yeah, we're putting here. We render tween here. So why would it start as not 0 now? Gosh, it's so hard. I don't know why it does that, man. It needs to set it right away, and it does, like, I wonder if we have another one called tween, and we initially assign it to tween. If we pass in as 0, if it would shut it up. We say, hey, player, you also need a tween value, which starts off at 0. Does that shut you up when we first make you? Doesn't. So, I don't know what to do. We're gonna say, we don't need this. Oh, no, we need this, but we need to set it to 0. We don't need this. I don't know why it does that, why it beeps right away. I don't know why it would do that. I don't know what to do, dude, with that beep. I mean, it's working. Everything except that initial beep is working perfect. Okay. Okay. I don't know why it beeps right off the bat, but I don't know what to do about that. I do think it'd be nice to clear up some of this unnecessary stuff before we commit. Let's look and see if we're missing anything weird before we commit. That was big. That was a big update. I mean, gosh, we've got such little time to finish. We've only got 3 days, but that's a big part of it. That's like the feature I was hoping to get out of this game. So if we can scale that to multiple biomes, then we just add the appropriate sound files, add a little bit of art, and then we probably won't get to do particle simulation, but it would be the same kind of idea, where we already have a tween value that gets louder or gets closer to a 1 when you're closer to it. So we can just set some particle emitters, you know, we can have some snow effects playing for the windy mountains, or wind playing for the windy mountains. We can have some snow in the forest or something. And then we can have what can we have? Another particle. Wind, snow. We can have a molten magma, floaty, I don't know, fireplace one or something. What does like a magma, being at a volcano, is that weather? If there's floaty, fiery stuff? That's another particle I'm thinking of. I'm thinking of different stuff. But we did this and need a biome class. Yeah, we did that. Tween value for each biome. So we've got the tween value. Sunny day, so we can set, like, let's say a lens flare for this pasture side. Lens flare opacity gets brighter the closer you are to the sunny patch, and it fades away. So it's kind of like the weather fading in a sunny day, and then snow in the forest, maybe. Something like that. Yeah, I had rainy forest. Maybe we do a rainy forest, or a snowy forest and a rainy waterfall area. Something like that, so we can have like some water splash as another weather effect or something. So let me just clean up. I don't remember what color this was or what color it's for, but it's off and we don't need it, so I'm just deleting it. I'm going to go to our player class, clean up some of our logic in our get pythagorean. I remember seeing a meme or something that said, like, I haven't used, yet another day I haven't used the Pythagorean theorem. And then I saw that and I was thinking about this project. I was like, I'm about to use the Pythagorean theorem in my everyday life. I'm going to keep this on because this is a kind of helpful framework for me to kind of think about it. I think it's going to be different than this, but we're going to have to play around and kind of figure it out. And then in our biome, I want to clean up this, clean up our biome function, or clean up our get pythagorean function in our biome class. But like, look at how easy that function is. We just assign a C point, we calculate an A length, a B length, and a C length, and we calculate it just with the Pythagorean theorem right here. And then we render a different biome marker and a biome. Each biome has a biome X and a biome Y and a marker X and a marker Y, and we just render little squares for there. Okay, so yeah, our code, if you want to look at our body of code, this basically is just setup. This is basically printing out debugging info and render info, but all the meat of the stuff is happening in our player class, which does input handling, and also has got a function to calculate the distance between a biome, and then our biome, which has a way to calculate the distance between our biome and our biome marker, which we then use to assign a value in between 0 and 1 in relation to how close we are to that biome. And then we're just playing a sound that's volume is set to be that volume. So yeah, this player.tween value, we need a player.tween value for each of the biomes. So we might do something different here. Instead of player.tween getting assigned, it might be self mountain tween, and we say this is self mountain tween, and then we say, no, we need to do, I think this is okay, because I think we need to say, god damn, actually, I don't know. It's hard to visualize how we scale this up, because we need to run the get pythagorean on all the biomes and we need to get high pot length on all the biomes. We need to run this one on all the biomes to get the marker Y. We need to compare it to our player's cLength for every biome. So I'm kind of just trying to figure out where we put all the biomes, and this is what I was trying doing here, where I'm saying, hey, player gets a value of called biomes that stores a bunch of different instantiations of all these different biomes and their markers, which I think can work, but it's hard to say. I don't know. Hard to say. The other option is we go into play state, we do all the biomes just like this, and then we say, hey, run this on all our biomes, which is probably the better route. But, you know, we're figuring it out. Yeah. It's looking good. You know, we play getting closer to this biome and it fades away. That's the biggest feature. So if we can get multiple biomes working with that, having it cycle through all the correct functions to calculate that stuff, making sure nothing's overriding one another, we can put in some different sounds, add in some different art, have it sounding much more weather-like very shortly. And then we need to worry about the effects, the weather effects, which is the particles, windy up in the mountains, snowy in the forest, sunny glare in the pasture, or whatever you want to call it. We'll have different area places to walk. Then we gotta, you know, control where our player can walk. I'm thinking of like a Super Mario overworld, Super Mario 3, where you just got a little overlay, so like you can walk up the path, up the ladder, over the bridge, that sort of deal. But we need to lock our input, our player's input, to something once we decide what the biomes kind of look like and we get those effects kind of working. But yeah, this is a good commit. We don't got too many nasty comments. We've got the old tween value, which I guess we can nix. Cool. I'm going to get everything. No, get A with a message saying added Pythagorean functions to calculate proper C value, cLength, and tween value for mountainBiome and player. And then I'm going to get pushed to our origin main, and I'm going to leave us a note saying that we need to I mean, I know we got to do it, but we got to write it. Like, we got to just say, contain all biome cLengths within object, and then iterate through all biomes with player cLength to set tween value. So those are the two things I kind of need to do, because the marker for the biome cLength shouldn't move. We just need to get those kind of hard-coded in there. And then we need to cycle through all the biomes with our yeah, so we need to run, this is exactly what this is. Our player cLength, iterate through all the biomes. So it's like this function updates our player's cLength. Yeah. Or it doesn't update our cLength, it updates our tween value based on our cLength. Which is actually. Oh yeah, it does calculate our cLength based on our current positioning. So this would give us our cLength between our player and our, yeah, mountainBiome. So I guess like calling this function get hypotlength, it doesn't, because it's not really getting, it's like assigning, it's assigning our cLength. So I guess it's okay to call it that. But what it's really doing, yeah, what it's really doing is calculating a cLength for the player cLength. Okay. So yeah, we need to make another biome and put all of the appropriate biome markers for that in its cLength and then compare. So like we need different cLengths for the biomes than we do for the player, but that's, I'm not too worried about that. I think we can figure that out. So yeah, so the next episode we're gonna add another biome. Values are working okay. And then once that is, once that's working, we can maybe add another biome, make sure 3 are working, then we can work on temp audio and then temp particle effects, which I'm hoping will be easier than, oh, I don't know. Hoping they won't be too tough because we only got 3 days. That's what I'm trying to say. And then, yeah, we'll add temp audio. So maybe for tomorrow, I might record or edit some temp weather audio, as well as make a little music for the overworld, and then apply those things, I guess. Because if off stream I record a little track for the overworld and I record temp wind, and so we want wind for the mountains, we want rain for the forest, and we want birds for the sunny pasture, I guess, and then we want like a running waterfall or something. But I might not add the waterfall. I'm just trying to see what we can fit in for this game jam while we've got 3 days left. So I might add the waterfall, I might not. Might record it, might not. I guess we'll see. But thanks for watching. We need to work a little more on this. Today was great though. It's just like, you know, if I only code an hour a day, I missed yesterday. If I only code like an hour a day, a 6-day game jam is just a 6-hour project, and we just did 2.5 hours right now. So it's like, you know, it's like you just really need to put the time in. If you're doing a 7-day project, how many hours do you want to work on it? Divide that by 7, and then that's how much you got to work every day on it. So it's a little humbling to learn. I mean, it makes sense. It's a lot of work. Thanks for watching. We'll figure out more tomorrow, but I'm really happy with the progress we made today, so thanks.